Hello, everyone. Glad to see you all back here. Today, we are very happy to have Melanie Morten talking about inclusive infrastructure, people versus place. I guess most of you are familiar with the setup, so no reason to repeat. We're going to go for the first 45 minutes or so, and I might ask some questions to Melanie, but then the last 15 to 10 minutes, it's going to be open mic. So please remember to just raise your virtual hand. We'll open up the mic and you'll be able to ask your questions. And without waiting too long, I guess, Melanie, you can start the sharing of your slide, and still people coming in maybe. But I guess we can get started and go to 5. Thanks, Melanie, for being here, and then thanks for the very early day. But take it away. All yours.
Perfect. Well, good morning, good afternoon, everyone. Thanks so much for having me. Today, I'm going to talk about the selection and resorting effects inside a city after there is a new public transportation and investment. So to set the stage, we're going to look at the bus rapid transit system in Dar es Salaam. Bus rapid transits, for folks who don't know, is what is on the back of the slide here. So you can see that there's a station with an elevated platform, easy on, easy off boarding. You can also see that there are 3 lanes that are bus-only traffic lanes. So this is essentially a form of public transportation that's better than a bus, but it's not quite an underground subway. And so we're going to look at the difference between how do we measure impacts of an investment like this on a location, and is that a different impact than impacts on individual people? This is joint work with a bunch of co-authors, Clare, Gharad, Caylee, and Bilal. And we know in cities, especially in low-income countries, especially in our context in sub-Saharan Africa, there's rapid population growth. And so on one hand, rapid population growth allows more people to benefit from the higher wages that can be in cities, and it could be a very exciting opportunity. However, on the other hand, as cities get larger, you have more congestion, you have more of what Iglesias calls the demons of density, so too many people. And if it's not managed well, it might be that the productive abilities of the city can't be realized because people just, for example, can't get around to where they need to go. And so as urban population grows, this means the government needs to build more public services. So they might need to provide housing, they might need to provide schools, they might need to provide infrastructure, and they might need to provide public transportation. And there's one feature of these sorts of investments. These sorts of investments are all place-based. So you can put a public transportation system to a neighborhood, but it's much more difficult to target people if it's the case that people are mobile within the city. So what does that mean? It might mean that you want to, for example, place more public transportation investment into a part of the city where lower income people are living, so that you can facilitate, for example, access to jobs. If you do that, and then what happens is that the rents go up and those low income people get displaced, you still treated the neighborhood with the public transportation system, but the people who are actually in that neighborhood appreciating the public transportation system might be different people. And so what we're going to look at in this paper is this difference between impacts on the place, on the neighborhood, and then impacts on the people. And again, we might want to think about who the government is targeting when they make place-based investments. Are they targeting initial residents? Are they targeting certain groups? For example, it might be the case that some investments get captured by men if it's unsafe for women to commute on public transportation. And then how do we think about who actually ends up benefiting once we account for all of the potential resorting that happens in a city? And so that's the question that we ask in this paper. Are we going to show a potential outcomes framework that lets us think about how we can separate out locations from people? And then what is the link between what we might estimate in a standard regression analysis, thinking about locations and how does that actually link back to impacts on groups of residents. And we kind of want to emphasize that in lots of cities, it's going to be the case in our case as well, there's very high mobility. So in our case, we have about 35 to 40% of individuals moving house over 3 years. In the US, if you look at renters, there's about 10% of renters moving house within a city every year. So it's very natural to think that the people who end up living in a neighborhood might be quite different than the people who start living in a neighborhood, especially when there's some big change that might change the value of an amenity. And so we're going to have two innovations in the paper. The first is a data innovation. So we did a lot of tracking of people so that we could follow individuals over time, as well as resurveying people who moved back into the original houses so that we can follow the houses, the physical structures over time, separately from the individuals who were living in those structures. And we're then going to sort of give a simple framework that lets us think about what exactly is the link between this place-based object and the individual object. We're going to have a focus as we go through on understanding gender impacts. I think that's important. We're going to focus on employment outcomes. There's often very different impacts, both in levels and changes of employment outcomes for men and for women. And so we're going to track separately men and women. There's a lot of urbanization in the world. So I think as development economists, it's increasingly important to think about what do we understand about how cities work and what are some of the different challenges about understanding poverty alleviation inside cities as compared to other parts of the country. But for example, here in Dar es Salaam, predicted city growth is about 80% over the 15-year period. In general, this pattern of increasing urbanization is around the continent and more broadly around the globe. Okay, so we're going to look in Dar es Salaam. And this is a picture of the proposed BRT system. We're going to be looking at the rollout of the first phase of the BRT system. So in a lot of the maps that I'll show you, they're going to have 3 lines that map to phase 1, phase 2, and phase 3. So phase 1 you can see is this top brown route. It essentially goes from the CBD along a highway, a main arterial road out to the neighborhoods, and it has a small offshoot. Phase 2 goes south, and then phase 3 is the purple line. The BRT in Dar es Salaam is the first BRT in East Africa, although these BRT systems are common around the world. And it started in April 2017, and it carries, in the phase that we're looking at, about 200,000 people per day. And it's a flat fare, no matter how far you travel on the route. So we were interested in understanding the impact of the BRT. And we wanted to understand the impact both for people who live nearby the BRT, but also because there could be a lot of resorting within the city for people who might live further away. So here again this is a map that phase 1 that we're looking at is the route that's along the top of the map, and then phase 2 and phase 3 are there for comparison. And so we constructed a sample where we went in equal distant radii out from the CBD. And at each of these circles, we interviewed and recruited about 12 to 14 households before the BRT opened, and they became our sample. So we've got a sample of people spread throughout the city, both close to where the BRT is opening, but also further away so that we can look at indirect impacts. And throughout the data work, we tracked both individuals and we tracked structures. So structure, just think of a house, so think of a neighborhood, but we're going to be specific and think about the house. And so, for example, it could be the case that in this first house, the same person was living in baseline and at endline. So that's easy. We go and survey the person in the house. In the second house, it could be the case that there was someone living at baseline who moves out, and then someone different living in that house at endline who has moved in. So we would have, in that case, an exiter and then an arriver. And we would track the person who exited to their new location. And then for the arriver, we're going to ask retrospective data so that we would get the implied outcomes for what would have happened to them before they moved in. Okay, we're going to do that for every structure. We're going to randomly choose one adult male, one adult female at baseline. They're going to be our tracking sample going forward. And so we're going to sort of do this exercise where we're trying to find the original male or original female in the structures, go forward, and then resurvey the places where they were starting from if they've moved out. So we do this, we survey, our baseline is in January 2016, before the BRT opens. And the BRT opens for operation in April. We do a midline primarily just to help with the tracking, and then we'll focus on the inline results that are collected in 2019. So let me just give a few motivating facts to sort of set the stage, and then I want to jump to how we think about analyzing the impact of the BRT, and then also how we can present a framework to separate out these two objects of interest. Okay, so first of all, in this context, commutes are long. So that suggests potential impacts from building public transportation. There are important gender differences in labor market outcomes and transportation. So that motivates an interest in tracking separately and measuring separately males and females. And then I'll show you some suggestive evidence that selection is important. The types of people that move into the houses that get the public transportation are different than the types of people who are moving out. So we have both a lot of churn in general, and then we have selection and selective in migration. And so that's going to be important because it means that there's a real chance that when we estimate neighborhood level effects, we're going to be mixing up selection with treatment effects. So these are maps of what happens. Actually, maybe let me stop there if there are any clarifying questions before I get to the motivating facts.
So far, it seems that everything is flowing smoothly. So
Perfect.
Go ahead.
Okay, so baseline commutes. On the picture on the left, here is Dar es Salaam. And again, if you remember, we're going to look at that phase one, which is the BRT line at the top of the figure. So at baseline, on average, people take about 15 minutes one way to commute to work. And you can see the patterns sort of, if you live closer to the downtown, your commute is faster. If you live further away in the outskirts, your commute is longer. We see changes in jobs between baseline and inline. This is, of course, two effects. Both people might change where they go and work, but if they keep working in the same location, their travel time to get there may speed up. This is just a map of what the flows look like. The arrows here, the darker colors are where people go to, and the lighter colors are where people start from. So you can see a lot of people are going into the downtown to work, but not everybody. Some people are commuting locally, some people are commuting reverse flows, but in general, the general pattern is that people move towards the center to work. The second fact is that women are both working less, but also have different patterns of how they get to work. So we find at baseline that about 85% of men are working, and then about 50% of women are working. But conditional on working, you can see that more than half of women are getting to work by walking. And a lot of men walk to work, but you can see that the rate is about 50%. Very few people in this context are commuting by cars. So the difference between the walking is going to be different types of public transportation. People end up using the BRT once it exists. So this is a picture on the left of asking everyone in our sample, did you take the BRT in the last 7 days? What you can see is that if you live close to the BRT, you're using it more. If you live within 2 kilometers of the BRT, about 60% have used it in the last 17 days. But of course, people are using it for many different reasons. One reason is to go to work, but people also use it for shopping, for education. So you can see that about 20% of people are taking it to get to work. Here is what our churn rates look like at the household level. So what do we mean by churn rate? We mean when we went back to the same house at inline, was the same household living there or were different households living there? So at the household level, we have about a 17% churn rate. At the individual level, the churn rate is at about double that, at about 40%. So in about 20% of the cases over 3 years, we go back and we see that an entirely different household is living in the house compared to at baseline. The other things that can happen is that households can split up. And so we might go back and we see one person from the original household still living there. But for example, the other respondent has moved out. So this is a lot of churn, but it's not uncommon for cities around the world. So again, the benchmark to the US is that there's about 6% of people moving house. And if you look at renters, about 10% of people moving house just within 12 months within the city. And so the sense that the cities are dynamic places and people are moving around means that we want to think really carefully about anything that's going to be neighborhood-based when we're thinking about analyzing cities, because there is a lot of movement that's happening in the background. This is just a map of where people are migrating to and from. Here, I think it's a little bit less stark in terms of concentration, but in general, the patterns tend to be, and you can see it here, that people are moving towards the outskirts of the city over time. That's a life cycle effect. The outskirts of the city are where there's empty land, and if you want to build a house, you would have to move out. But you can see that this sort of flows all around between different parts of the neighborhood. And then the last motivating fact I'll show you is motivating facts for selection. And so again, what we're plotting here is, on average, is there a change in the education level between the people who live in the house at inline compared to at baseline? And if there is a change in the education level, that would suggest, for example, that people who are moving out are getting replaced by people who could be more educated. And that might be a signal that, for example, some of the neighborhood effects are going to be driven by selection. There's then, of course, a question of whether that selection is purely observable or whether it depends on unobservable other factors. And so you can see here that, and we'll show this in regression format as well, but along the first phase of the BRT, you can see that on average, the people who move in are more educated than the people who are living there at baseline. Okay, so that sets the scene. And so now let's think about what we want to do, which is to measure or answer the question, did the BRT increase employment in Dar es Salaam? So we're going to build up this argument in a couple of different steps. The first step is going to be asking—
Melanie, a very quick question. Someone, Laszlo Alpern, asked if there's a school bus system.
A lot of kids are using, these are adults. So this is not a kids effect. This is education of adults that are going there. Children use different modes of transportation to get to work, some of which would be the BRT to get to work. I'm not sure if there's a formal school bus system in the setting or not.
Thanks.
Okay, so we're going to think about 3 different objects. So first of all, when we say, did the BRT increase employment, what do we mean? So one thing we could mean is, on average, did employment go up in the locations that got a BRT compared to the locations that didn't get a BRT? That's going to be a neighborhood level effect. And that would be a really common object to estimate if you had cross-sectional data, because you can run sort of difference and difference regressions at the neighborhood level over time. The second object might be to ask, did the BRT increase employment for the people who were originally living near it? So that's more similar to an intent to treat outcome. For people who live near it, did it actually improve employment outcomes? Or did they end up, for example, moving away, and so they didn't benefit from the BRT? And then the third object could be asking, did the BRT improve outcomes for the people who end up living near it at endline? So even if I wasn't an original respondent, so I might not have been a targeted person, if I chose to move to the BRT, did it make my employment outcomes better? Or was I the sort of person who was already having high employment outcomes, so I didn't actually have a change in my employment outcomes? So those are going to be the three different objects we want to measure, and we're going to think carefully about how they each relate to each other and relate to the data that we would normally use to estimate them. Okay, so that's going to be people versus place. Okay, so who does the BRT benefit? It can benefit the neighborhood. It could benefit the initial people. It could benefit the final residents. Or it could be that all of the, if we find, for example, neighborhood effects, but we find no effects on final residents, that would maybe suggest that all of the estimated neighborhood effects are coming because of resorting, not actually because of gains to people who live there or people who started living there. Okay, so to get there, we need to think about how to measure the impact of the BRT. I'm going to go through this a little bit quickly, but let me just give you a gist of what we do. So we measure exposure to the BRT. Obviously, the BRT is not put randomly in the city, and in a city, it's quite difficult to think about random exposure to the BRT. So what we're going to think about is we're going to think about the other potential places that the BRT is getting built, so the other lines, and we're going to use average exposure over the whole network and use that as a control for, as well as actual realized exposure just from phase one. We're going to run difference in difference regressions. So we're going to have conditional balance pre-trends. So we're going to do machine learning for what variables should we include for our conditioning set for the pre-trends. And then I'll show you the framework for thinking about selection. Okay, and so this idea that infrastructure is not random, it's pretty obvious, right? It's difficult to be in a city where everyone's interacting. For example, the BRTs need to go down main roads. So if you're living near a main road, you might already have different access to commuting, for example, by going in car or by going in private transportation. It could be the case that what's happening is instead of travel times improving because of the BRT, there has been a reduction in congestion, maybe, and travel time in private cars is going up. So we would want to be careful about mixing up travel time with attributes that are related to, for example, living near a main road with the BRT. It's also the case that there is, even if we did have exogenous measures of where the BRT went, there's going to be some people who are just going to be more exposed no matter what happens. So for example, if you live in the CBD, you're going to get public transportation shocks, pretty much any possible realization of a public transportation network. So you're going to get a public transportation shock in this particular realization, but in any other way that you could have designed the network, you would have also got a public transportation shock. So we can think about using the equivalent of randomization inference to demean the fact that some people are just likely to be more exposed no matter what. Okay, so that's essentially what we're going to do, and that follows Borshak and Hall's approach. Once we do that, the picture on the left shows what would happen on average across the city when you have the full BRT system rolled out. And essentially what we want to do is we want to demean what actually happens when you get phase one with what counterfactually could have happened. And that's going to give us this deviation from expected reduction in travel time. And so this is going to be the picture on the right, the main object of interest that we look at.
Melanie, can I ask you a couple of clarifying questions? So one is Gianmarco, then I have one on myself. So Gianmarco is asking whether the BRT are built on existing roads that have been essentially made bigger, or it's like in expropriating some properties. Did you have a sense on how the new BRT lanes are going to be built? Oh,
Yeah, so in this case, for phase one, there was wide medians. So they took out the median of the highway, not the highway, they took out the median of the road. For phase two and phase three, there were more issues with, they needed to expand the road a little, and then there were some issues with informal settlements along the side of the road.
I have a question on data collection that I should have asked before, probably. So when you speak about neighborhoods, are you speaking also about like firms placing different neighborhoods? Is it about firms or economic activity also changing, or is literally, people versus whatever happens to people where in the neighborhood?
We're going to be focusing on how do people get affected based on where they live. We're not going to survey firms. You could survey firms, and that would be really interesting. It just would be a really big exercise and a different exercise than what we did here. So we're going to think about people having exposure to this new technology based on where they live. In the background, there would probably be firm resorting, and so part of that would be part of the story as well in terms of understanding how the city as a whole reacts.
I guess the reason I'm asking is sort of knowing where people work, right? So basically, I understand you don't know where people live, and then where they commute, but do you know both? I mean, do you know exactly where they work?
Yeah. So this map, for example, here. This was the commuting flows at baseline. So that's showing like where does someone start living, where do they work in? So we have that information. We're not going to do very much with that today, but we do have that information for both baseline.
That's a way to think about it then, yeah.
Mm-hmm. Yeah. Okay, perfect. Okay, so we do conditional pre-trans. For the conditional pre-trans, there's a large number of potential variables to condition on. So we're going to use post-double selection lasso to decide what controlling variables to include. And that's going to be our way of including control variables. Within, I don't have the results here, but they're in the paper. We then used a pre-round of data that was collected by the World Bank to check for whether or not the conditional parallel trans holds, and it holds between a pre-period and period there. So you can think about this as a sort of a spatial difference in difference, trying our best to account for the endogeneity of where roads go, and also accounting for potential pre-trans and certain characteristics. So we then want to think about how do we sort of conceptualize this idea. And so this is what I've said a couple of times. We have the neighborhood effects, which we're going to think about to just be really precise. What are the outcomes at the house, the physical house level, and before and after the BRT? And then we're going to ask, what are the outcomes on the initial people who are living there? So that's the intent to treat. And then what are the outcomes on the final residents who are living there, which is the treatment effect for people who end up being exposed. And we want to ask again, if these things are different, what does that tell us about selection? And then what can we learn from the data that we collect about whether the selection is observable or unobservable? And that's important because in lots of cases, you might think that you can include covariates such as average amount of education, and that might control for selection. So we want to ask empirically, is that true? What are you getting back if you do that? And how does that map to these other objects of interest that are well-defined based on particular populations? Okay, so to do that, we have an outcome. We have a measurement for person J who's in location I measured at time t. So if we think about a standard repeated cross-section, if someone stays in the house, they're living in the same dwelling, they're the same person J, and so we see them at baseline and inline. In a repeated cross-section, if there's an exiter, we only see them at baseline. If there's an arriver, we would only see them at inline. And then if we were doing the neighborhood, this is just sort of being very clear, but we would have potentially different people at inline as baseline, because if there's movement in and out of the structure, we're going to have whoever is living there at the time that we survey them. So we have these two missing cells that we want to fill in, and that's what we did with our data collection efforts. So we first of all followed the people who left, the exiters, and that lets us find out what would have happened, what happens to the person who was living in location D at time t, that ends up in a different location at time t+1. And then we want to know what did happen to the people who came in. And so we ask retrospectively to everybody that it's going to be most important for the arrivers, what were you doing? So that's the new person when they were living at an initial location. And so that's going to let us be able to define the within person outcomes as well as the within structure outcomes. Okay. So let me show you, first of all, just what happens in terms of rent, in terms of travel time, and then let's get into what happens in terms of employment outcomes, and then what can we understand about selection based on the different types of employment outcomes. So we're going to sort of show, first of all, just the structure level results. These are like neighborhood level results, would be a really standard thing to run. So first of all, did it indeed get faster to go downtown once you have access to the BRT? The BRT connects neighborhoods to downtown. So this is a sanity check that people are reporting that their commutes or their travel time just to get downtown for any reason decreased. And so this is in column 1, you can see that this is the variable reduction in log travel time. This coefficient of minus 0.94 is a little bit difficult to interpret. So what we put in the bottom of the table is the average effect for a highly exposed person. So a highly exposed person at the 80th percentile is about 0.1. The variable of the mean is about 0.1. So it's just a way to scale this estimated parameter. So someone who's at the 80th percentile of treatment, using our adjusted treatment variable that accounts for this potential exposure, experiences about a 10-minute decline in the time to travel to downtown. And the base value is about a 71-minute trip to get downtown. So you can see it's a relatively sizable reduction of about 10 minutes off 17 minutes. Okay, so the BRT does speed up travel along that route. The second column asks whether or not the rents or the cost of living near the BRT went up. So again, we're using the mean variable. What you can see here, the average effect for highly exposed, this is in logs, so it's about a 19% increase. So if you're living if you're in the 80th percentile of exposure, on average, rents are going up about 19%.
Melanie, there's a related question by Ivania Nassier. She's asking whether are there renters, are there landlords when they move away, are they selling house, or,
So we see much more, we track carefully renters and owners. In this context, a lot of people they split houses. So there's one household that has a couple of different families, and it tends to be that there's an owner, and then they will rent out rooms to different houses, and those people are renters. So there's much more mobility between the renters than the owners, about double as much mobility. And we have in the paper sort of separate results thinking about owners and renters. This outcome variable here, we ask for everyone. So if you're an owner, we ask you what would be the rent of your house. So it's capturing both owners and renters.
Thank you.
Okay, so the BRT is improving times to get downtown, but it's also increasing the cost of living. So there's a potential then for selection. Let's sort of look at these different objects of interest and ask if it's changing employment and earnings. Okay, so again, we have these 3 different objects that we care about. The impact of the BRT on the dwelling. And so that's just holding the dwelling fixed. Potentially there's a new person in the dwelling, and it's just doing the difference. Final person minus initial person within the dwelling. Initial residence is just looking within the person who was living there at the start. What is their inline outcome minus their baseline outcome? Final residence is what is the outcome for the person who ends up living there versus what happened to them before they moved. Okay, and so thinking about employment. So this is a variable, are you usually employed? If we look first of all at column 1, column 1 is the neighborhood or structure level effect. And we see a large positive effect there. So again, just to get the magnitudes right, it's probably helpful to look at this number at the bottom. So on average, 2/3 of the population are working. And if you're at the 80th percentile, there is an increase in employment rates of about 7 percentage points, which is about 10% of the total. So it looks from the cross-section data that there's a large impact on the BRT is changing the likelihood of working.
Right. Do you mind like explaining once more what it means to be highly exposed in an interpretation of the finding, this question about this?
Yeah. So the d-mean variable, has a distribution. It's a little hard to interpret directly because, for example, some people can have actually a negative d-mean exposure. So the negative, if you're someone who lives really close to phase 2, on average, across the whole system, you're going to expect some exposure, but you didn't actually get exposed with phase 1. So in that case, you're someone who's actually less exposed than expected from this. So this d-mean variable has a distribution, but includes some people who are going to be, they're less exposed now than they would be in expectation, and some people who are like that. So what we do there is at the 80th percentile of that distribution is a d-mean variable of exposure level of about 0.1. So 0.1 just lets you scale this number here by about 0.1 to give you what that is for someone to just scaling it by 0.1, which is approximately the 80th percentile. So someone who's very exposed at the 80th percentile of this variable is getting at the structure level 7 percentage points more likely that someone in that structure is working. Okay.
Thank you. Thanks.
Okay, so BRT improved outcomes. Wonderful. However, if we look at the initial resident, we find no statistically significant impact of the BRT on employment. So again, on average, about 70% of initial residents were working. There's a smaller point estimate, a 2 percentage point increase in employment, not statistically significant. And then if we look at final residents, we see again, there is no statistically significant improvement in employment. Okay. So what does this suggest? First of all, it's telling us that there's a difference between neighborhood and individuals. So when we're thinking about what we want to measure from the BRT, it's showing us that these 3 things are potentially different. And a way to reconcile the patterns that we see is that final residents were already working more before they moved to the BRT. So going to the BRT for the final residents didn't improve their employment. They already had high levels of employment. However, the people who moved into the BRT were working more than the people who were moving out. So there was a positive selection effect at the structure. That would be a way to reconcile this one with this one. And then the initial residents, some of them got displaced. They went further away, so they didn't get to capture that gain. Okay, so all of this is gain saying that, sure, it looks like the BRT changed at the neighborhood level, but it didn't maybe actually increase outcomes for any particular group of people. And this could all be driven by resorting in the city. So I'm going to skip earnings. They're in the paper, a similar pattern. And now let's sort of think about what this means for selection. Okay, at the neighborhood, we see large impacts on employment. But we see
do you mind showing the mean again? Are the exiter working less than, no, they're not working less, so they're not all old and the one that move?
The ones who move, let me show you that in a second about the selection. We've got some figures on that.
Okay.
Yeah. Okay, so we now have these 3 different objects are giving us different answers. We want to understand, okay, some of that could be from selection. If so, is it selection on observable characteristics? And is one solution just to control for average exposure to education? Is it observables on other, is it selection on other observable characteristics that we may be able to measure? Or is it potentially selection on unobservables, which would be quite difficult to measure? Okay, so I think this is going to answer here the question about selection. So in which ways are the people who move in different than the people who are living there at baseline? So what we show here is, for example, if we look at men to start off with on the left, the people who move in relative to the people at baseline are no more likely to have been employed. They're a little bit more educated, the people who move in, than the people who move out, but it's noisy. We can look at whether or not they were someone who was a commuter at baseline, working outside the house. And then we can look at age. So for men, we don't see too much evidence of selection. Where we do see more evidence of selection is for women. And in fact, I don't think I'll have time to talk through the gender impacts as much, but most of the employment effects that we measure are actually driven by women, not men. So what do we see? We see a positive effect on employment. The magnitudes here are a little bit different just because of how, employment is 0-1, years of education is, so it looks small, but it's the people who move in at endline are more likely to have been working at baseline than the people who are living at baseline. The women who move in at endline are more educated. They're slightly also more likely to have been people who were already commuting. So people who were already working outside the house if they were working at all. Okay, so that's suggesting that there's potential changes both on observable stuff, which might be things like education, but also on some of these other outcomes. Like, for example, are you the sort of person who already works outside the house? That is potentially observable, although not something that we often have in cross-sectional data, especially to capture the changes for people who move in and the people who move out. Okay, so how do we link up the neighborhood from the structure? So we have, this is just going over what I talked about before, we have the impact of the BRT on the dwelling, which is the difference within the dwelling, potentially with a different person. The impact of the BRT on the initial people, and then the impact of the BRT on the final residents. And so what we can do is a potential outcomes framework where we're going to add and subtract. This is, for example, the dwelling effect here is holding the dwelling constant. There's potentially a different person, J prime. So we're just going to add and subtract the counterfactual effect for the person who was living there at the initial time, where they end up at the endline. We'll just add and subtract on this term here in the second row. And what does that give us? If we rearrange it, it gives us the treatment effect on the initial resident, and it gives us a selection term. And the selection term says, what is the difference between measured at time t+1, the person who is living there at endline, minus the person who was living there at baseline? And that also includes the fact that there's some potential migration across neighborhoods. Okay, so what does that say? It says that the dwelling effect is related to the initial resident effect plus a selection term that captures endline differences. So that's natural. The initial resident moves somewhere else. We want to account for what happens ex post. That includes selection, potentially on observable and unobservable characteristics, as well as potentially a migration change. So that gives us a way to think about, we have the initial resident that we can estimate. We have the dwelling that we can estimate. Can we construct, through observable measures in our survey data, a selection term that lets us recover the initial resident effect from the dwelling effect? And that's going to be the exercise that we do. You can do a very similar thing. Instead of adding and subtracting the person who was initial resident, you can add and subtract the person who was the new resident. And then you would just get a slightly different selection term that measures changes at baseline characteristics rather than changes at endline characteristics. So that's what we're going to do. We're going to just ask, we'll start with the dwelling effect. We're going to add on different covariates. And we're going to see if we can explain the selection with the goal of recovering back the initial resident effect. And this is an exercise that we can do because we have the tracking. We're going to see how far we can get without tracking data. So just a preview, we're not going to find that controlling for years of education is enough to get us there. So we're going to look, for example, at what happens with neighborhood changes. To control for neighborhood changes, you need to know where the initial resident goes to at time t+1. That's a pretty difficult thing to get unless you track the people, because most people in cross sections are not going to know that. You may have more luck asking retrospectively, where were you living, and going the opposite way to go back to the final resident than to go forward. But let me show you that. Okay, so we're going to start with the structure level results. So this is just showing you the point estimate. At the structure level, we saw that we had a large impact on employment. Okay, let's ask what happens if you add in controls for years of education? How does that change our outcome? So that's this estimate here. Basically, we get still a very positive, significant effect of the BRT on employment, controlling for demographic variables. This is education and years. So these would be the sort of standard cross-sectional controls that you can easily include. We then ask, what happens if you adjust for the fact that some of what's happening is the person is getting displaced to certain characteristics? And there you can see that the point estimate goes down a little bit, but you would still conclude that the BRT has a positive effect on individuals, even including the fact that there's a neighborhood migration effect. Putting both of them in together still yields the fact that the BRT, you would conclude that the BRT has a positive effect on employment. But yet we know, because we tracked the initial person, that at the initial resident, there was no impact on employment. So what does that tell us? It tells us, in this case, that simply controlling for the most easily observable controls, the demographic ones, is not sufficient to get us back the initial resident effect. Even controlling for things that are a little bit more difficult to track, such as where the person got displaced to, which is part of the difference of the initial resident, is not sufficient. And in the paper, we go through a lot of other controls, such as this idea about, are you somebody who is generally a commuting type? So we control for the fact that there might be differences in commuting types. We might be differences in employment and earnings and things like that. So we go through a lot of different controls. And again, it's really difficult to ever get back this initial resident effect. So you would end up concluding that the BRT has a big impact on employment. But if the goal with these selection controls is to get back this initial resident effect, you wouldn't end up qualitatively getting the same answer. Okay, let me just skip to the conclusion. So infrastructure is inherently place-based. However, whenever we're doing a place-based analysis, we probably don't have as our policy interest, parameter of interest, what actually happened to the neighborhood. I think we're thinking, what happened to people, and did the employment effects actually increase the number of people working, rather than just, is this BRT causing resorting but potentially not increasing aggregate employment? So policymakers may care about targeting specific people. They may want to know these objects of interest, what happened to initial residents, and then what happened to final residents? Did anyone actually benefit from the BRT? And there we're showing that it's quite difficult conceptually to think about how to measure those outcomes unless you are proactive about what data you collect. If you want to estimate the initial resident effect, then you need to track people forward. If you want to estimate the final resident effect, you can track people by asking retrospective data. However, simply having the cross-section and putting in observable controls in this setting is not enough to recover either. I didn't show you the final estimate decomposition, but it's not enough to recover either of the objects of interest on individual people. And this is going to matter for our qualitative conclusions. Did the BRT, or does investment in stuff that's attached to a neighborhood in general, improve outcomes? And for that, we want to be really thoughtful about how we're understanding the potential scope for selection and these different objects of interest. So let me stop there, and I'm happy to answer questions.
I think Gharad goes first,
Hi, Melanie. It's fascinating project. So I was wondering, as someone who absolutely hate commute, like the idea of a change of employment is one thing, but it could also change like what type of job you do, whether you open a business versus you do something else, and also just like value of time, no? Like even if I change no job, but not spending so much time in commute, like, more of a welfare outcome than a job.
Yeah. And so actually, we do a little bit of work on this in the paper. What's quite interesting is most of the employment effects are actually driven by women starting to work. However, it looks like those jobs mostly are not jobs that they need to take the BRT to get to. So instead, what happens is women are much more likely to report that their satisfaction with public transportation options in general has improved. And they're using the BRT for many things other than just working. So they're using it for all this other stuff that they're talking about. And what actually happens is that women are starting to work, but they're working in jobs that are self-employed, that are close by. So it seems that the BRT, and for that group of people, may be actually exactly your channel, like freeing up more time in parts other than just working. And as a result, people are then able to be increasing employment, but it's not necessarily directly coming through a channel of commuting from A to B to work, but coming through this broader package of what public transportation can do. So I think that's really interesting. And there's sort of work a little bit on, lots of the frameworks tend to focus on getting from A to B for work. But for example, there's work in Japan using cell phone data that's measuring the fact that you might go to work, but along the way you might stop at grocery stores, and transportation might help you to do repeated things. And so some of these other things are also valuable in terms of what people appreciate.
Very interesting. And Nicola has the question, I think, next.
Yes. Thank you, Melanie. Super interesting. So I was wondering if you see this, like you can say anything about the structure of the household, like meaning like, do they have children or not? And then you could imagine that these decisions, depend on whether your kids are going to be closer or farther away from school, and whether or not you have looked at that.
Yeah, that's really interesting. We were really interested in looking at effects on kids' education. I think we didn't end up seeing anything on that per se. I think a lot of the mobility effects are primarily driven by renters moving in and out. So renters are much more mobile. Those tend to be people that are like often, because how this housing market works, people can rent a single room. Those are often, but not exclusively, like single person households. So those are people who are particularly mobile. Those are like often like unmarried men, can be unmarried women who are living by themselves and then are a little bit more flexible. So I think it would be interesting to think a little bit about, that might be something, for example, household structure might be an interesting control variable that you can observe, especially in a cross section. And like, for example, if that was helpful in predicting outcomes, then maybe that would be something that would be easy to do. So when I showed you this picture here with all the different controls, we haven't actually done that one with household controls, but thinking about repeated cross-section of the household structure, who's in the household, might be something easy to add there and interesting. So thank you.
Makes sense. Thank you.
I think this is actually super important for any general worker looks at place versus people. I think it's essentially very relevant. Even like in structural transformation stuff, people think about places, not people, and so on. So it's fascinating. It's super cool. I sort of the question that Grant's asked before is a lot about like the general welfare statement, what happens, and sort of it seems like women start to work more close by, like they don't really use BRT for that, but I guess one side of the story is that the economic structure of the neighborhood changes and potentially clients are brought into that. So that's why I was asking the first question earlier on is about economic activity. How does it change given the BRT? And you can see how that could change in a sense of more self-employment in the neighborhood because more clients are brought in, and that might actually, that might be interesting. I don't know whether you're looking into that for the work.
Yeah, so we're not so I think that's empirically what you see. So women in general, about half of them, 55% of them in general are working in self-employment if they work. So it's the most common thing that they do. And then these results I didn't show, but I was talking about them. The increase in employment is primarily driven by women, and it's driven by women increasing self-employment income. So there are two things that could be happening. One is that it could be this effect of the neighborhood is changing, richer people are there, et cetera, et cetera. The other thing that is kind of important, and we put questions in the survey, but we haven't been able to, there's not sort of enough to do much quantitatively there, is that most of the type of self-employment is doing small scale retail. And the BRT in some sense also acts as a reduction in trade costs because it goes to the main downtown wholesale market. So we did have a whole module about, is it perhaps facilitating, even though they're working close to home, is it facilitating some of this like travel back and forward? So it looks like they're not commuting, but they might be using it to go and get the goods. And like, for example, it's faster. So if you're selling things like fish, it's faster to go on the BRT. It's like your fish are fresher. And so you can potentially go and do that. So that, it could be some of those channels. We did try to put modules about that, but quantitatively, we haven't kind of got something too much to say there. But I think it's definitely a potential channel that some of the self-employment outcome could be related because it's allowing them to purchase stuff more easily. And that would look like they're still working close to home, but it's still there. So I think it's like interesting. I think there's sort of more to do there. We know what they're doing, where they work, that sort of thing. But yeah, it would be really interesting to do a little bit more there to understand that.
Is there a natural stopping point along the BRT line? So in the middle, you have to stop for like an extra 5 minutes because whatever, there's some sort of change in the driver or something like that. I'm just thinking about this natural way that the specific little bit of the neighborhood close to this stop will evolve more than others. Like if there are natural stops, like people may actually use stops to do things. I don't know whether that's true. I mean, of course.
Well, that's really interesting because what actually happened is we don't have data on this either. It would have been great to collect firm data. And we did think a little bit about if we could do satellite data for this, but we didn't. We had drone data, but the drone data was only post, not pre. But anecdotally, what was happening was that the transportation before this was minibuses that would stop anywhere along the road. And so there would be more spread out commercial activity. Once you have these BRT stations, they're about 1 kilometer apart. And so you end up getting sort of hollowing out where there's more retail towards the stations and less in the middle because there's not as much foot traffic in the middle.
Yeah.
And so I think that would be a really interesting phenomenon. We don't have a great way to do that unless we could measure it from the air of like what happened, but like it could be the case that in our case, we're not picking up, I don't think we've got that variation. I mean, we have a good sample of about 2,000 households, but it's still not, they're spread out over the whole city, but you would want to maybe think about people who live close to an actual stop, not just close to the line. And are there different effects if you're right close to the stop and then these things are spaced out about 1 kilometer? But again, I think that might be, one thing you sort of realize is it's quite difficult to get enough sample size when you start going down to that level. And so that's an argument for thinking about, can we get better administrative data or are there other ways to measure just, it's really costly, time consuming to do all this tracking of individual households. It's really difficult because people are super mobile. What other ways could we think about data that might let us answer some of these questions? And like, for example, the work in Bogota has very nice administrative data, so they can kind of get at, when you have census data at a really fine geographical level, you can look at much more along the route variation. So it's a great idea. I don't know if we can do too much with our data, but it's a great idea in general.
Yeah. It's fantastic work, actually. Any remaining question from anyone? I can't see any raised hand, but I might actually be missing something. Nope. Otherwise, thank you so much, Melanie. Melanie cannot stay in the Zoom. She has a prior commitment, so unfortunately she can't really stay on.
I can stay for like a minute or two, but I'm
okay.
happy to stay for a minute or two. But
it's all right. I think it's all right. No, don't worry.
Yeah.
Yeah. Thank you so much. We're gonna have. Oh, you see it here. So in 2 weeks' time, we're gonna have the last VDEV of the season, I believe. Correct me if I'm wrong.
Yes.
It's gonna be another fantastic talk. So far, thank you, everyone. Thanks so much, Melanie, for this fascinating talk. This is going to be important work, I think, as usual. So thank you very much, and I'll see you in 2 weeks. That's
perfect. Thanks, everyone.
Bye-bye. Thank you.
Ciao.